Welcome to School of Civil Engineering. As we have started a response spectrum and pushover analysis by using Etabs, so this is its last video, and in this video, in our previous video, I have shown you that how we'll analyze our video, and we have completely analyzed and model and done everything. So in this video, I will discuss about that briefly with you, and that's why I have take time for this video. So if you're here, that means you have completed my previous 6 video. So thank you very much, and support me, rest with me. So let's start for our video. So I will open our previous model. That is our previous model, and you're seeing that it's locked. That means it's like that in our previous analysis. So directly now I'll go here, analyze display, and go here for deformed shape. So from deformed shape we'll select case, and this for dead load, apply. If you see that this is the from for dead load, and after that if we go here for pushover analysis in X direction, they have a step number. We have to select a step number and absolute, maximum, minimum, and this is the number of our step number, and this is the our step number. I mean they have 15 steps, we all know that. So after that apply here, click apply. So you are seeing that there have some option here, A, V, C, D and E point. Now what is the point and what is the color mean? I will discuss with you that in brief. That's why I've taken time, and okay, I'll go for discussion. Before that I'll show you everything for POY, and it's showing B, C, D, E point, and if I select and apply, it's showing that for life safety point, this for IO, it is the initial point, this is the life safety point, and this is the collapse prevention point. This is showing for step number 4. So I'll give it for step number 1, then press apply. Okay, then for step number 2, so in this way we'll be able to see our data, but I will show it in later. But here I will select B, C, D, E point. Okay, apply, then go for okay. Now it's done. So I'll go for next term. Here display, they have many options. First of all, the hinged result. Here is the hinged result. Here is the statistics pushover curve. Here is the plot function. Here is the combined Storey response plot and the Storey response plot. They have many value for our pushover analysis. So we'll see that one by one. So first of all, if we go for hinged result, here or this for our hinged result. So first of all, we have to select hinged result for POX, this hinged result for POX, and hinged DOF. So we'll select for M3, and here is the Storey hinge identification. Here is the Storey 1. Suppose if we select Storey 5, if we select Storey 4, if we select Storey 3, in this way the hinge result will be changed, and here is the hinge auto select option, and after that relative distance okay, everything are okay, and the two lines are representing different things. The two lines representing the different thing, and if we cross that, from here we can found our, and for pushover Y, this for pushover Y, this is the curve for pushover Y, and I'll cross that. And I'll go here, display here a statistic pushover curve. So for a statistic pushover curve means our capacity curve, I mean base shear and monitor displacement, base shear versus monitor displacement. So for here we can found the data. This for base shear versus displacement, this is FEMA 440EL. This is the curve for our that value. So from here we're able to found our data, and you're seeing that this is our this line are representing capacity, single demand. After that we are able with this for X, and if we go for Y, this for Y curve, this for Y, this is the capacity curve. Here you're seeing that from that point it's going down, spectral displacement and spectral acceleration. And after that if we change that and has the plot type SA, SD, SA, ST, you can found what you record, and from here also you can change the plot type. This for NTC, this the curve for NTC, and after that this is the curve for EC8 targeted displacement, and also you can change for ASC, American Society for Civil Engineers, their represented curve. So unable to calculate targeted displacement, inadequate solution did not cover us. Okay, done. And in this way you'll be able, and this for okay, it's unable to calculate, and for X this is the curve for base shear versus displacement according to ASCE, and from here you have to just according to requirement. Suppose this is the acceleration S1, this for acceleration S1, you have to input the value. You have to input that value here according to code, and then you'll found your capacity curve. Like that you can found your capacity curve, and if you want to export that you have to click here, show report, detailed report, and from here you'll be able to copy that. Okay, I think then from here export to Word by clicking here, you have to save. So it's done. I'll cross that. I'll cross that. After that I'll go here for a Storey response plot. That's the important things here. Here the main important thing. So it's showing displacement is the Storey displacement from base to Storey 5, and it is the displacement, and it's showing displacement of our building So from here you have to select displacement type, maximum Storey displacement. From here you have to select the data and case or combo. Sorry, from here we have to select at first POX. This is for pushover analysis, displacement for pushover analysis, and this is the maximum Storey displacement. This is the maximum Storey displacement. The maximum is 0.3 inch for 5th story. From here is the maximum Storey displacement for POX. If we change that for maximum Storey drift, this is the maximum Storey drift. And if you don't know about what is the maximum Storey drift, I want to tell that in short. So this is the difference of the Storey displacement. This is the difference of Storey displacement with the present Storey with the top Storey. Okay, present Storey with the top Storey. What is the Storey displacement difference? It's represent that. And after that, if you go here, Storey share, this is the Storey share. For x-axis is the overturning moment, this for overturning moment, and this for stiffness it will be 0. Okay, it is also 0. They have no Storey stiffness. So if we go for y, also we'll be able to find our value. For y direction, it's showing the displacement of our building, and for our maximum Storey drift, this is for maximum Storey drift, and this for Storey share. Okay, this for Storey share. So like that way you'll be able to find your required data. So if I close that, and if we again go display combined Storey response plot, so from here you'll be able to find that. And if you open that animation, so you'll be able to show that the difference of our Storey. So it is the load step, it's showing load step for load step POX, and if we change that y, this for y direction and load step, it's showing the load step. For 4 load steps in direction x, for y it's direction for y, it's showing the change of our building Storey data for record value. So this is for displacement, this is for drift, this is for shear, and this is for overturning. Okay, so we have done everything. Now we are in main thing, so we'll go display deformed shape POX, then BCDE. Okay, and apply. It's okay here. Now I'll open it. File. Here is the force displacement curve of a hinge. For hinge, you are seeing that here A point, B point, C point, D point, and F point. This graph are representing graph for building performance level. So if we go here, you are seeing that there is A, B, C, D, and here is E. So B to C, if we go here, B to C, from B to C they have 3 points, IO, LS, and CP. I mean intermediate occupancy. If we go here, intermediate occupancy level, LS means life safety level, and I'm just taking time here. You can read that by by pause your video. Then life safety level, then this for collapse prevention level. Okay, so from here intermediate level, life safety level, and point at this point represent collapse prevention level, and here is the point. You can also read that in details. So by reading that, you'll be able to know about what point represent what. I think it's clear to you. So if we go here and if I select that point, IO LS CP, apply, okay, then press OK. Now I'll go for this, this for Y. Now I will see for X, display, where deformed shape, that's for X, apply, okay. So for PX, if we go here, if we go forward, I have checked for 10 steps, but they have no step for that our building are being failed for our pushover in X direction. So if I go here again, deformed shape, and if I check that BCDE, apply, you're seeing that if I go back again, so in here in the step 8, step 5, it's showing some plastic hinge, formation of plastic hinge, but it's from B to C. So this is the intermediate occupancy. I mean, this point do not affect our building anymore. So if we go again, it's also B to C, again till 10. It's showing our building are totally safe according to X direction. So now I'll go for Y direction, POY, apply, okay. But for Y direction, we're seeing that they have some point which have the red mark. That means at the time of earthquake, our building will be fail, or our frame will be fail in that point. I mean, it will go beyond. If I go here, what the point E represent? Point E represent the total failure of the structure. After this point, hinge breakdown, I mean total fail, it will show the total fail of this point, okay. So if we see that point, we have to recheck our design, or we have to analyze our design again, and you have to increase the frame size, or you have to do some prevention measure. I mean, you have to increase the beam size, or you have to increase the column size, so like that. Or you can change in Y direction, you can change the column shape, okay. So in this way you'll be able to reduce that. So I think it's clear about pushover analysis, and also its curve, and also its hinge point, formation of hinge point. So if we go for step for point 1, they have some point B to C, and if we go for next, from step 2, it's showing some red point, and also showing for C to D and E. If we again go point 3 and point 4, and point 4 in our downside, it's showing in our downside our building showing some failure for our pushover analysis, I mean for a nonlinear statistic analysis. So I think it's clear to you, and if you have also any problem about pushover analysis or nonlinear statistic analysis, then you can comment me below. So thank you very much. In next time I'll come with you with a new tutorial series. So stay with me and support this channel. So thank you very much. Stay connected till next video.